Do you need to solve an AP Calculus AB volume by cross-section form the area between curves problem, but you don't know how?
No.
Okay, well if you would like an explanation, I'll give you one anyways.
So first of all, we should just go over some definitions and rules to know.
If you think you have these definitions and rules to know down, you can just skip to the timestamp on screen. But if you're not sure, I recommend you continue watching. So first of all, the integral is the limit used to find the area under the curve of the graph of a function. So this entire expression is the integral. The integrand is a function that is to be integrated. So that's whatever terms are in here. The bounds of integration are the lower and upper limit of the area of a function that will be integrated. So those are right here. They're also called the limits of integration. They just represent what you're integrating from and to on the function. In terms of x is an expression made using only x and constants. In terms of y is the same, just with y. So in an integral, this is represented by the dx or dy. So dx is in terms of x, dy is in terms of y. And also in the integrand, you'll notice that if it's in terms of x, all of these terms will either be an x or just a number. So like whatever, 2, I don't know, 4, I can go on and on. So for example, this bottom expression is in terms of x because y is isolated. And on the other side of the equation, we only have x's and constants. So if you wanted to make this expression in terms of y, you would subtract y from each side so that x was isolated. So that would only be y's and constants on one side. A cross-section is the 2D shape created after taking a straight, infinitely small cut of a 3D shape. So a cross-section will always be a 2D shape that represents an infinitely small cut of a 3D shape. So for example, if you look at this 3D shape, if you take all of the horizontal cross-sections of it, they'll all be squares.
So next is vertical and horizontal. I have some technical definitions here, but basically vertical is like a straight line that goes up and down, and horizontal is a straight line that goes left and right. I think of it as like the horizon, and then I just remember that vertical is the opposite of horizontal. And lastly, parallel and perpendicular. Parallel is two lines that, if expanded forever, will never meet, so they have the same slope. And then perpendicular is two straight lines that intersect at right angles. So their slopes are negative reciprocals of each other. So now on to the rules to know. First, we need to know how to find areas between curves.
So if one function is on the top and one function is on the bottom, we subtract the bottom function from the top function. Then we place that in an integral, put dx, and then the x coordinates of the intersections we use as the bounds of integration. Then just simplify that integral and you get the area between the curves. Now, if one function is on the left and one function is on the right, we take the left function and we subtract it from the right function. Then we find the y coordinates of the intersections and use those as the bound of integration. And then we use dy in the integral and then we just solve.
So the second rule to know is finding volumes by cross-sections. This is the main portion for solving problems like this. So if a solid has a known cross-sectional shape, let's say like all areas perpendicular to the x-axis, it's a square, between two curves f of x and g of x with area a of x, so the area a of x is what we found in the previous step, then the volume is the integral from a to b of a of x dx. Now the same thing applies with cross-sections perpendicular to the y-axis. It's just that the functions and bounds must be in terms of y. And lastly, saying perpendicular to the x-axis is equivalent to saying parallel to the y-axis, and vice versa. So to solve these problems, you need to know all of these areas so that you can calculate the area of the cross-sections.
If you think you have these down, just skip to this timestamp. But again, I recommend just sticking around.
Now some of them are obviously easy, but others you might need to be able to derive or just have memorized. So we'll just go over each of them quick. As you may notice, they're all in terms of the base, because the base of the cross-section, which is either going to be the top function minus the bottom function or the right function minus the left function, is going to be what you use to plug into the integral. First of all, squares, it's just base squared. Second, rectangles is base times length, and length is specified some way in context. So the length could be 3 times the base, or it could be 3, or whatever. Then the area of a semicircle, so this says the area is pi r squared, which translates to 1/4 pi times base squared. But since it's only half of a circle, it's half of that area. So it comes out to actually 1/8 pi base squared. Now on to equilateral triangles. The area is the square root of 3/4 times base squared. I usually just memorize it, but you can derive it by like drawing the diagram and then like filling out appropriate lengths and such. Lastly, the only other areas you need to know are for isosceles triangles. Either the hypotenuse will be the base or the leg will be the base. If the hypotenuse is the base, the area is 1/4 base squared, and if the leg is the base, the area is 1/2 base squared. So now we can actually get to the process of solving these problems. So the first step is to sketch the function diagram. So basically you just want to sketch out all the functions and whatever lines the problem gives you. Obviously you don't need to do this if the graph is given, and then you just draw the cross sections in the appropriate way given by the problem. Second is to draw the 2D shape. So basically you just draw the cross section given by the problem. And then you just label all of the required lengths and identify the correct area formula for the 2D shape. So those are given on this. Then for step 3, you have to find the area formula of the 2D shape. So for this, you need to find the length of the cross-section's base, which is either top minus bottom or left minus right, depending on if the cross-sections are vertical or horizontal. And then you need to substitute that base formula into the original area formula. And then lastly, you just need to integrate to find the area. So you set up the integral by placing the area formula for the 2D cross-section into the integral, and then you find the bounds of integration using the intersections of the functions, which are either going to be the x values of the intersections or the y values of the intersections, and then you just integrate. So that's a general process for solving problems like this. If you want to take a deep look at that infographic, I'm going to put it in the description of this video. And make sure to comment any ideas for future videos, or if you're struggling with anything in math that you would like some help with, I'm happy to assist. So like, subscribe, and apart from that, take care.